Areas and volumes of similar solids. We've talked about similar figures quite a bit, actually, in this class. Anyone think they can put to words what similarity is?
Like two figures that like may have like that are like not congruent. But,
Not congruent. You're right. Not congruent.
Same dimensions, different size, like the
same
what's the word I'm
angles.
looking for?
Like
They did have the same angles. They're
Yeah.
proportional. There's the word,
Yeah.
okay? Figures that are proportional are similar, okay? So we are looking at figures that have the same shape. So they look very similar to each other. They look very much alike. They're not the same figure. They're not congruent figures, but they will have the same shape. They just won't have the same dimensions. Their dimensions will be proportional. Okay. One little fun fact for you. Every cube is similar to every other cube. So think about that. If all your dimensions are the same, 2 by 2 by 2, and you get another cube that's 5 by 5 by 5, you're going to have the same ratio the whole way through. 2 to 5 is 2 to 5 is 2 to 5, right? Same goes for spheres. If you're saying these two spheres are similar, every two spheres will be similar because a radius is the thing that you're comparing, right? So the radius never changes no matter where you put it. So if it's a radius of 2 and a radius of 7, 2 to 7 is 2 to 7 is 2 to 7 on to infinity, okay? So cubes and spheres will always be similar to each other, not cubes similar to spheres. Cubes to cubes, spheres to spheres. Okay, first example then. You have these two figures, and the question is, are they similar? And if they are, I want to know the scale factor. Remember scale factor, right? Okay, so take a look at what we know. This 3 would correspond to what dimension? The 6. So 3 to 6 would have to equal, this 3 would correspond to this 6. And the last one, the 2, would correspond to the 4. Are those equal?
yeah.
What's your scale factor? 1 to 2, right? This is 1/2, this is 1/2, this is 1/2. So we would say, yes, they are similar with a scale factor equal to 1 to 2. It's a weird similar, sorry. Okay, so look at letter B there. The 2 corresponds to what? The 3. So 2 to 3 should equal 3 to 6. Right there, you should be done with this problem. Why? Because they are not equal. 2 to 3 and 1 to 2 are not the same ratio. So as soon as you prove that the ratios are different, you don't have to go any further. You could, right? You could say 2 to 3 also, but you really don't have to. As soon as they're not similar, they will just not be similar. There's no way to make them similar if something about them is not proportional. Okay? Okay, this next thing should feel very familiar to you. If you think back to, it was 10-4. That was 10-4. I think I said 11-4 in my last class. We talked about a scale factor, a perimeter ratio, and an area ratio. Do you remember those in chapter 10? The scale factor was the same as the perimeter ratio. What did we do to scale factor to make it an area ratio? We squared both parts, okay? Today, we're going to take the scale factor and square both parts, and that's going to represent an area ratio. It's surface area, but it's area, right? Volume ratio, if you think about it, we're cubing the units to get a volume. So your volume ratio is going to be your original, your scale factor, cubed, okay? And I think where most of the problems lie in this is people try to cube this one to get to that one. A squared cubed is actually a to the 6th power, okay? Make sure you always go back to the scale factor before you try to find a new ratio. So if my scale factor is 1 to 2, then what's my surface area ratio? 1 to 4. 1 squared to 2 squared is 1 to 4. So with a scale factor of 1 to 2, I have a surface area ratio of 1 to 4. How about the volume?
1 to 8.
1 cubed to 2 cubed is 1 to 8. Okay, so notice we came back to here. We did not cube the surface area. We cubed the scale factor to get our volume. All right, so now look at this next problem. This says find the scale factor if the volume ratio is this. Now think about it. What has happened to a scale factor to make it volume?
Cube.
It was cubed. How do you undo something being cubed? You cube root it, okay? Now, you can plug this in one step. I don't recommend it, okay? I would, if I were you, cube root the numerator and cube root the denominator. Okay, but it is possible to do this. You just have to make sure, if you're going to do it this way, that you keep the whole thing under the radical, okay? I would do this one. What do you get when you cube root 3375?
15.
That's 15. What do you get when you cube root 1728? 12. Do you remember how to plug that in? This is the one I showed you a couple minutes ago. 3, the second key, the caret key, because that has this above it, okay? And then you type in the number. So if you have trouble with that, let me know. And if any of you have a different calculator, your calculator might do it different than the TI-30 XIIS that most people have. Would you say this is your scale factor?
No,
Simplify, okay? Take that ratio as low as it will go. So 15 over 12 reduces to what? 5 over 4. So that is going to be your scale factor. Any questions on that? Okay. This next one's my favorite one. But it's probably also the trickiest in terms of just how many steps you do and what order you do them in. So stick with me here. I believe you are fully capable of this. It says the volumes of two similar solids are 40 and 135. If the surface area of the smaller figure is 48 square inches, what is the surface area of the larger figure? The volumes of two solids are 40 and 135. The surface area of the smaller one is 48. What's the surface area of the larger one? Now, do you have a scale factor, an area ratio, or a volume ratio right now? You have a volume ratio, yeah. Your volume ratio is 40 to 135. Do you think that's your actual volume ratio? I mean, it is. There's a better way. What should you do? Reduce that, okay? Those are both divisible by 5, so you get 8 over 27. Okay, so now let's think about this. We were saying scale factor, surface area, and volume. Okay, My volume ratio is 8 to 27. What do I need? What? We need the larger surface area. So eventually we need a surface area ratio because I know nothing about the dimensions of this figure. They didn't tell me, you know, this length and that length and that length. All they told me was volumes and areas, right? So we don't have dimensions. You cannot just plug it into a surface area formula. Instead, we're going to use ratios. Because we know they're similar figures, those ratios are going to help us find it. So if I know a volume ratio, but I need to get to a surface area ratio, what's my first step? I need to get to here first, right? I need a scale factor. How do I make a volume ratio a scale factor? You cube root. Okay, so that means I'm taking the cube root of 8 over the cube root of 27. What's the cube root of 8? 2. What's the cube root of 27? 3. That is your scale factor. They told me the surface area of the smaller figure, and they asked me to find the surface area of the larger. So what do I need to do with that? I need to square it. My surface area ratio is 2 squared to 3 squared, or 4 to 9. Okay, so that's what we're going to use because we're trying to find surface area and we know one surface area. So I'm going to set that up as a proportion. 4 to 9 equals what to what? Where is that 48 going to go in my proportion? On the top. They told me this is the smaller figure, so I want it across from the smaller of my two numbers in my ratio, okay? So I put an x down here, and now I cross multiply. 4x equals 432, and then I'm going to divide by 4. So x is 108 what? Squared. Square inches. This is a surface area, right? So inches squared. God bless you, Max.
Can you zoom in on the exponents of it? I can't really see it.
Right here, these ones?
Yes.
Yes. So this is squared. These are cube roots. That's a 3 and a 3.
The surface area ones are squared.
Yeah. How do we do? It's a process, right? You just gotta stop your brain from going too fast and think, okay, how do I get from volume to scale factor to surface area, right? What do I gotta do? Yes.
Can I use the restroom?
Yes.
Is the next one super easy or am I missing something?
Pretty easy, but you just need to understand the wording.
Oh, okay.
But yes, it's pretty easy. Okay, this next one says Office Max sells paper clips in small and large boxes. A small box holds 220 paper clips. First of all, what is that talking about? The volume. Okay, so this is the volume of the small box. The large box is formed by doubling the dimensions of the small box. How many paper clips should fit in the large box? It's not 440. What do you think, Michaela?
Is the equation, 220 over x equals 2 over 1? Find it?
No,
1,760.
it is 1,760. How'd you get that?
2 squared. There's 2 cubed. Sorry.
Right. Okay, so here's the deal. Your trigger that needs to go off when you see this word is scale factor. Whenever they give you information about the dimensions, it's your scale factor, right? They're saying the length of a side. So if I have a box and I have a box and they tell me the dimensions doubled, if this is 1, then this is 2, right? My dimensions are doubling, not my area, not my volume, just my lengths. That means that my scale factor, because it is doubling, would be 1 to 2. Okay? So if I have a scale factor of 1 to 2, but I just said I know a volume, what do I have to do to that? You got to cube it, right? 1 cubed over 2 cubed is 1 over 8. So this is your volume ratio. You're going to take that and you're going to set it up as a proportion. Where does the 220 go? On the top. It's your smaller, right? So it needs to be across from the smaller of the two. And this is your unknown. Now you cross multiply. So you're going to go 1 times x is x. 8 times 220 is 1,760. What? Paper clips. Okay, so that one doesn't have a whole lot of like undo, redo because you started with a scale factor. So you just got to cube your scale factor and set up your proportion. Lots of proportions today. Okay, you should be setting up a lot of proportions in the homework. Yes. Yes, if you want to turn your notes in right now, go for it. I didn't make them due until next week, Thursday, because of the tech fast. But if you want to submit them right now, submit them right now. I just didn't want you seeing that they were due and then you're supposed to not be on your device. So.